Lesson 26 consists of trinomial factoring and overlapping right triangles. I'm going to start with trinomial factoring. It's called trinomial factoring because you got 1, 2, 3 monomials, so trinomials. This is the factoring you are probably more accustomed to. So look at example 26.1. It says factor x squared plus 6 minus 5x. Well, the first thing we always want to do in these trinomials is get it in descending exponent order and x value order, if you want to look at it that way. So we're going to arrange it x squared is first, minus 5x plus 6. This is the order we wanted. X squared, x, no x. And then we factor. Now what we do when we factor is we create these parentheses and we say, okay, what multiplies to be positive 6, multiplies to be 6, but adds up to be negative 5? What two numbers multiply to be 6 and add up to be negative 5? So these are going to be factors of 6. Well, 3 and 2 are factors of 6. When you multiply 3 and 2, you would get 6. However, if you add positive 3 and positive 2, you would get positive 5. So what we need to do is say negative 3 and negative 2. When those are multiplied, you would get positive 6, but when you add them together, you would get negative 5, which is what we're looking for. So you would say negative 2 and negative 3. And then your first part in each one is always just the x, okay? You just put the x first. Because if you remember, if you were factoring, or if you were multiplying these two quantities here, you would FOIL it, and you do first would be x times x, x squared, outside, negative 3x, inside, negative 2x. Those combine to be negative 5x, and then last, positive 6. So that is how you factor a trinomial. Let's look at another one. All these examples will kind of add one thing. Gives us negative x squared plus 5x plus 14. Okay, well we got to factor this, but there's a negative here. Well, what we can do is factor out the negative. We can get rid of the negative by saying negative 1. We take that out, put it in parentheses, and we see what is left. Now when we factor out the negative 1, you're essentially dividing everything by negative 1. So this becomes positive x squared. This becomes negative 5x. This becomes negative 14. Notice if I was to multiply negative 1 by all three of these, it would go back to the original expression here. So from here, now we can try to factor this trinomial, leaving negative 1 here. Try to factor this trinomial. And so we say what multiplies to be negative 14 and adds up to be negative 5. Right? Multiplies to be negative 14, adds to be negative 5. Okay, what are factors of 14? 7 and 2. Okay, well one of those is going to have to be negative to equal negative 14. And if we do negative 7, for example, negative 7 times 2 is 14. Negative 7 plus 2 would be negative 5. So therefore we could say x, well, we've got two parentheses, minus 7x plus 2. And then we got the negative 1 there. And so we get to this point. Now what we got to do is multiply the negative 1 back inside of it. It's really easy. All you do is multiply. Well, actually, truth is, you can leave it in this form, but many people do like to multiply the negative 1 by one of the other factors. So this would work, or you could multiply the negative 1 by one of the factors. So you could say, if I multiplied this here to negative 1 times x and negative 7, you would get negative x plus 7, and then you'd have x plus 2. this would work. So just a check mark for both of those working. Or you could multiply the negative 1 over here and say x minus 7, negative x minus 2. That would also work. So 3 different answers. I was confusing there for a second. But any of these would be acceptable. Most of you are probably just going to leave it at that. That's totally cool. That's what I would do. So moving on to example 26.3. Okay, it gives us that trinomial there. We know that we got to arrange it in our order. So negative 3x squared plus 6x plus 24. Make sure you bring the negative with the negative 3x. Okay, now here we have a negative for our x squared value. So we're going to take out the negative, but we also have a 3 in front of it. Well, good for us, the 3 factors into the 3, the 6, and the 24. It is a factor of all those. It's divisible by all those. So we can take out actually a negative 3. When we take out a negative 3, we're left with a positive x squared. Okay, divide this by negative 3, we're left with negative 2x. That's all we're doing, dividing the 6 by negative 3 in a sense. Divide the 24 by negative 3, negative 8. And so now we're to this point. From here, factor out. Yeah. That didn't help any. Okay, what multiplies to be negative 8 adds up to be negative 2. I'm just going to go ahead and do this one for you. Just quick. Negative 4 and 2. Positive 2. Negative 4 times 2, negative 8. Negative 4 plus 2, negative 2. Then you add the negative 3 over there, and that would be your answer. Negative 3 times x minus 4 times x plus 2. Last example, 26.4. Once again, rearrange it now. These all have x squared or higher. So what you got to do is find the highest one, x to the 4th. Negative 2x to the 4th. What's the next highest exponent? 12x cubed plus 32x. And so now we got it in our proper form, 32x squared. What can we factor out? Want to factor out the negative. The 2 is divisible into all those, so we can take the 2 out. Now all of them have at least 2 x's, so we can factor out x squared. Negative 2x squared, we factored that whole thing out. What are we left with? Took out negative 2x squared here, so we're left with positive x squared, which is what we want every time. Took out negative 2 from 12, so minus 6, and we took out 2 x's, so we're left with 1x. 1x is what we want there, and then the x squareds here cancel. 32 divided by negative 2, negative 16. And then, same question. What multiplies to be negative 16? Adds up to be negative 6. Let me start with the x's there. Let's see, negative 8, positive 2, negative 8 times 2, negative 16, negative 8 plus 2, negative 6. Bring down the negative 2x squared. Here you have your answer. Negative 2x squared times x minus 8 times x plus 2. That is trinomial factoring. Let's move on to the next concept. Overlapping right triangles. We've talked about overlapping triangles before. And what we said was when you have overlapping triangles, that they're similar because, well, this angle is the same. And both of these are right angles in the big triangle and little triangle. So therefore, by angle-angle similarity, we can say that the little and big triangle are proportional. We got to find A, B, and C. So those are showing you that they're similar, so they're proportional. What I would do to start this problem is always draw each triangles. So I have little triangle here. Hypotenuse is A. The height is 6. The height is 4. The base is 6. Got our big triangle. The hypotenuse is actually the sum of A and B. So A plus B, and that's a little different. The height is C, and the base is the sum of 6 and 4. Add those and you get 10. So now we have our similar triangles divided up, so it's easier to see what correlates. So the ratio we're going to use, well actually let me say this first. Is there any way we could solve for A really simply, or really easily? Do we know how to find a third side in a triangle when we already have 2? Yes, we do. We use Pythag. So we can use Pythag here. So 6 squared plus 4 squared equals A squared. So we solve that out. 36 plus 16 equals A squared. 36 and 16 is 52. Square root. So square root of 52 is A. We actually do not have to simplify that. Can leave it as square root of 52. So we have solved for A. So now I'm going to write this, or write in our A spots, square root of 52, square root of 52. So now that hypotenuse is square root of 52 plus B. Now let's solve for, let's go ahead and solve for C, since that one's going to be easier. We just find our ratios, okay? Between the 1 tick mark in the box, the right angle, is a 6 on this side, and on this side it's a 10. So we write 6 over 10. Y'all want to reduce that? I thought so. Let's go ahead and reduce 6 over 10 to 3 over 5. Reduce that to 3 over 5. Little numbers, always better. So we got 3 over 5 from the base. Now, what corresponds over here? Okay, the height for each of them, we got 4 over C. 4 over C would be a ratio. So we can, or correspond, so we can use these in the ratio. So we cross multiply. 3 times C is 3C. 5 times 4 is 20. Divide by 3. Another funky answer, 20 over 3 is C. 20 over 3 is C. Alright. Now we got to solve for B. B is going to be nice and fun. Let's stick with our ratio we had, 6 over 10. We reduced that to 3 over 5. And now we got square root of equals square root of 52 over square root of 52 plus B. So we're finding that last hypotenuse. What we're going to do, cross multiply. 5 times square root of 52 is 5 radical 52. That equals 3 times radical 52 plus B. 3 times radical 52 plus B. So we got to put that in parentheses. I'm going to go ahead and erase here. I'm going to kind of go back and forth with this little part. So 5 radical 52 equals 3 times the quantity of radical 52 plus B. We distribute and get 3 radical 52 plus 3B equals 5 radical 52. Just moving this over here, keeping it clean. Okay, Here's where it kind of gets interesting. Both of these are the 3 and the 5 are tagged along with the radical 52. Remember, if you have the same radical, those are like having the same, that is saying that they are like terms. So what we can actually do is subtract 3 radical 52 over here, because what happens, they're like terms, so therefore it's 2 radical 52 equals 3b. 2 radical 52 equals 3b. Okay? Then we divide 3. Divide 3. So you got b equals 2 radical 52 over 3. Now from here, unfortunately, we cannot call that our final answer. We actually have to simplify the radical 52, but it'll take no time. Factors of 52, you got 2 and 26, and then 26, 2, and 13. So we have 2 2's, and the radical 13 remains under the radical. So we take this, okay, that's 2, multiply it here by this 2, you get 4 radical 13 over 3. Okay, that is a simplified. And so that would be our answer for B. 4 radical 13 over 3. And there would be all of our answers. So that's how you do overlapping triangles for the right triangles. Just a little extra step there that's a little trickier. But hopefully you got that. And that is all that there is to lesson 26.